Okay, it's recording. Hey everyone, welcome to the Secret Store CSI community meeting for October 29th. This is a CNCF meeting, so it falls under CNCF Code of Conduct, and the video will be published to YouTube. Rita's going to help us with taking notes. Looking at the agenda, I think we have only one item for now, so please feel free to add as we progress. So the first thing on the agenda is basically to go over the GA stable proposal for the CSI driver and also for the provider. Let me share my screen. Can you all see my screen? Awesome. We talked about very briefly about this proposal last week. So basically what we've done is we've tried to add a list of items that we think should be done before we can cut a stable release for the driver. And also this lists a couple of criteria that the providers should complete so that the provider can also cut a stable release. Did anyone have any comments, or did you get a chance to look at it already?
I'm realizing that I do not have comment access on this doc. I did get, I think it's anyone with a link can view at the bottom there. And then you click change, and then viewer, you can change to commenter.
Okay, it's done.
Thanks.
But yeah, I mean, we can go through it now and you can add your comments as well.
Yeah, I meant to look at this more this past 2 weeks and got distracted. But yeah, I'm game to look through this now too.
Yeah, sorry, I'm in the same position. But yeah, also happy to look through it now.
Okay, yeah. So going over the list, basically for the driver, what we propose is right now, first thing is high availability, right? Because the CSI driver is in the actual path where when applications get deployed, and if the CSI driver is not up and running, or if it's running but it's having issues, then this could lead to downtime for the applications in terms of new deployment as well as upgrades. I think one thing that we really need to focus on is making sure it's resilient to infrastructure failures, network failures, and other operational failures. Also, it's running as a daemon set. So there's one replica running on each node. So we just need to ensure that when multiple controllers are updating the single Kubernetes secret, they're able to do that gracefully, and even in term when there's conflict, they're able to do an update. Also, I think when we consider this part, we also have to ensure that the number of API calls incurred is not too high, because Kubernetes returns a 409 conflict, and then we have retries in place. But I think one thing we need to verify as part of load tests is these retries don't bring down the API server eventually, just so that we reach an eventual consistent state. So this is what ensure retries for critical API calls without exerting too much load on the Kubernetes API server. And in terms of, again, in terms of API server load, what we have done already in the code for rotation or the sync controller is try to do filtered watches wherever possible. So we try to only filter on pods running on the same node as the driver. And then also for secrets, we only filter on secrets with a particular label. So I think that way we ensure that the memory growth is not too much based on the cluster size. But I think one issue now is controller runtime doesn't offer option to do filtered watches. So filtered watch can only be done with client Go. And I think at some point when controller runtime does support, we will pick that up. But I think we also want to review the existing code to make sure that we are only watching for the required resources. And we also need load tests to just ensure that scenario for large clusters. And this was basically just to make sure that when the driver calls provider repeatedly due to some errors, or if kubelet is invoking it, we basically have to make sure that we have enough checks to see if the operation's already complete, and if it's not complete, and if we send the entire gRPC call to the provider, then it's idempotent. So the provider can handle scenarios where certain objects have already been mounted to the pod, and then the rest of them are being rewritten, but the provider should be able to handle such scenarios as well.
That's an interesting one for Vault, because we've got dynamic secrets. So yeah, not sure like implementation wise how we could do that. Have you had any thoughts on dynamic secrets already?
So could you elaborate a little bit more on dynamic secrets? So when it's something that Vault changes automatically?
Yeah, sure. So like a common example is you might have a database dynamic role set up, and every time you read the database credentials path, it will create a new user and return a JSON blob with username and password back to you.
Okay. So in that case, if the provider is called repeatedly, basically for every call, we're going to generate a new set of credentials, and then it's just going to keep overwriting until it succeeds.
Yeah. So I guess it depends on how partial a partial failure can be. Like if we ensure that kind of the units of like retry are around like whole blobs, so something that includes both the username and the password.
Right. So I think that atomicity that probably still is dependent on the provider, right? Like if the provider actually knows that these two keys belong to the same object in the external secret store, then probably the write for those particular keys have to be atomic. So write all or write nothing.
Yeah.
Instead of just a partial write. Because when I say partial failures today, like for Key Vault, maybe is if they provide two objects and out of that one of them is not available in Key Vault, then we write the first one, but we fail the entire gRPC call. So then the driver fails the mount and says it's not succeeded, right? Like, so the pod is still not starting up.
Yeah, I think that's a pretty reasonable take on it. Just something to be careful about while we're doing the provider side on our side. Yeah, sounds good.
Right.
Yeah, I just had a comment there to try to capture.
Cool. Thank you.
Is that a feature that you can configure, or does this happen all the time?
It varies from kind of endpoint to endpoint. Most databases support both static and dynamic roles, so it just depends how the user wants to set it up for their database.
And then Anish, am I right to your suggestion was like that just partial failures should fail the mount. That may create extra database users that should get cleaned up by Vault later, but that
yeah, I think the extra database users wouldn't be too much of a concern because they should have a TTL on them, so they should get cleaned up automatically. Yeah, I think as long as we have atomicity on mounting all parts of a single credential read, then we should be all right.
Okay, thanks. I just tried to capture that.
Yeah,
go for
thank
it.
you.
Yeah, thanks, Liz. That looks good.
So I think my question is, partial failure is still going to fail the mount, right? Like, so if out of the objects provided, even if one of them results in a failure, then the driver still says fail to mount the whole volume. Okay.
Should we add this to the bottom then?
Okay. So moving on to the next one is basically performance. So this comes back again to load test, right? So we basically want to determine the system failure at scale and address these issues. So what we want to do is run tests against large clusters and also with large workloads. So for large workloads, I think there are a couple of different scenarios. One is basically just having lots of pods, so probably 5K to 10K pods. So that's a large cluster with pods. And I think because we also have watches on other custom resources, we also want to have a scenario where we have a mix of large number of secret provider classes and pods, so that we can ensure that we're able to handle such scenarios. And I think what we also want to do is all the features that we support optional today, which are not enabled by default. What we want to do is we want to enable all of them by default. So run the driver with all the features enabled and run load tests, basically to set a benchmark on the memory and the CPU usage. And I think what we want to work on from there is to see further optimization in terms of watches, and then ensure that the API server doesn't crash. And then in scenarios where there's a burst, we want to ensure that we're able to handle that burst gracefully by having some kind of rate limiting at the driver. Okay. Yeah, Tom, do you have any questions?
Yeah, I was just going to say sounds good to me, and it'd be nice to kind of publish in our README as well some of these benchmarks as well.
Yeah. Cool. So the next one is a very important one. So the testing part of it, right? So basically, what we want to do is determine all the test gaps and improve the test coverage. So that includes E2E as well as unit tests. So for E2E today, I think so we use BATs, and then we are also trying to cover all the features, but there is no coverage for all the providers in the driver. So basically, we are only testing with some features with some providers. So what we want to do is basically figure out which all features have not yet been covered, and then add E2E tests for all the providers with that. And the same applies for unit tests too. So there are, I think our unit test coverage is pretty low now. There's only like few packages which have unit tests. So I think what we want to do is open GitHub issues, or have contributors help us out, as well as we can pick up some of the packages and then get the unit test coverage up so that we are confident when we make changes the next time. I think for this one, also the next step is basically the PR that we have for moving to Ginkgo. So I think that's the next right step forwards in terms of ability to add new tests more easily. So it's under review. Hopefully we can get that merged soon, and then we can add more tests with the new framework. So this is basically the point. So we should have the same test coverage for all the drivers with all the current supported providers, so that we have more coverage from there. And right
Sorry,
now,
hey, question about the previous one, like where you said enable all features and determine memory CPU usage, right? Does that also imply that we will be running this with all the providers, all the supported providers?
no, it's only for each individual provider. I mean, the load test will probably have 3 instances, right? One per provider.
Right, but what is the expectation for running it with each provider? Because it may have different impact, right, on the.
So I think the metrics for load test is, I mean, the impact could be around latency, right? Like one is latency, but also the other one could be in the API server, because I know GCP provider queries the API server for service accounts. But other than latency, most of the other metrics should still rely mostly on the driver side of it. So the provider load tests are different, where the providers basically determine what kind of load they can accommodate when they talk to the external secret store, right? So that's where the rate limits come in, and how many calls concurrently they can make to their backend, Azure Key Vault or GCP secret store, right? But apart from that, in terms of driver metrics, I think these load tests will help us determine CPU, memory requests and limits, and then it'll also help us make sure that we have filtered watches, and then in case of high load, the driver doesn't crash.
Sure. I guess it's also like because we're enabling all the features, that implies this is only going to be tested with providers that have implemented all the features.
Right.
So we should just make that very explicit, I guess. I'll make a note here.
Okay, thank you.
Yeah, I was also going to say the individual providers now will need their own memory and CPU limits. So that'll be, I guess, on us to determine what is appropriate.
I think that should be at the bottom, like the provider section, where the provider test will then determine that.
Yeah, it looks like it does have that.
Right.
Yeah.
Okay. So for testing today, we test against so we build a kind cluster and then we test against it. So that means it's testing the latest Kubernetes version supported with kind, and also it's testing the latest for the driver. One test that we want to cover is basically backward compatibility. So to see that upgrade from N-2 version, minor versions of the driver, to the current version does not break any existing workload. So it still continues to work, and then new pods work with the new latest driver. So this is something that we want to test, as users are constantly upgrading their driver versions. And in terms of how we deploy the driver for E2E, today we deploy it with Helm, but also currently in the driver repo, we support deploy manifests. And there is no way to validate if these deployment manifests are valid. So as part of the E2E test, we all want to do deployment with Helm and then test it out. And then we also want to do deployment with the YAML files and make sure that they are also valid. But right now we stage everything in manifest staging directory. So
yeah, wait, the integration tests right now don't use Helm, or they do use Helm?
The E2E tests use Helm today. So in the make file, we have an install driver which installs it. And then the provider is just applied using kubectl apply.
Okay. So if the providers all need to have Helm charts too, the E2E should probably use those, or like.
So I think, yeah, so I think that's where the disconnect is. So the providers do support, if the providers do support Helm chart, I think we still want to test out just the Helm charts and the YAML files in the driver repo. So that's everything under manifest staging directory. So for driver test, we still install the driver separately and then the provider. For the provider, we could use the Helm chart or the kubectl apply, whichever the provider wishes to use. But for the driver, we probably want to test both, where we do Helm, and then we also do a kubectl apply on a different cluster to see both of them work. Okay, and then basically determine test flakes and deflake the test. So we want our E2E runs to be more reliable. So instead of relying more on the retesting scenarios. So in the last week we had to do retest quite a bit, and we've pushed a couple of PRs in effort to deflake the test, and then now they're a little more reliable. But I think we basically want to avoid sleeps or other non-deterministic weights in the test, and then switch to a more deterministic where we have retries and basically wait on a pod to start or wait for something to happen. So that way it's more reliable. And even for the wait, we set a particular deadline. So within that particular time, we expect that to happen. If it does not, then we know that it's an actual valid failure. And the last one is this is for the driver is the ability to run the E2E test locally. So today, I think for HashiCorp Vault provider, it's still possible because everything is set up as part of the E2E test suite. So BATS sets up the keys and loads it, and then it runs the tests against it. So, but for Azure and GCP, I mean, the two providers, but also for every other provider that gets added, I think what we need to make sure is there's a way to run the E2E test locally for the users, new contributors, so that they get some confidence before they open a PR. So I think this is basically adding the option to run it locally and also providing documentation for new contributors so that they feel confident to contribute. And then the next one is documentation, basically. So we want to document all the feature gaps and known limitations. Some of the known limitations we do communicate with the user on GitHub issues, but if we can document that, then it's easier to just point them to that link, and then we can just keep growing that list if there are issues. Then the next one is basically best practices guide. So based on our testing and what we think is the right way to configure, we should probably write a best practices doc so that we can point users to it and say how to configure their secret provider class, how to do it within the namespace, and also best practices around the secret provider class and external secret store. So basically, we want to say use one secret provider class per external secret store, or how to split around. So basically, it's just going over general best practices that we think, and then we can keep adding on to that list as we add more features to the project. Then today we have a couple of readmes. Apart from the main readme, we have a docs folder which goes over all the different features individually. So what we want to do is we want to consolidate all of those and just host it on an Netlify site. So I have an open PR for it. And right now I'm in the process of requesting a Netlify account from Kubernetes org. Once they do that, we should be able to see a preview on every change in the PR. And then we can use that to basically see what the rendered web page will look like and then go on with that. So I think this will also provide us the option to write more docs for each individual feature. Like we can go as elaborate as possible. Yeah, and then this is the docs for new contributors. So this will be around how they can start contributing to the project and also how to run the tests locally based on the changes that they make. So the update demo in the README currently has a demo GIF, but that's outdated. So I have a PR that I'm working on to update that so that when users just land on the repo, if they want to take a look, they can still see the entire flow from deploying to actually viewing the secrets in the pod. And then troubleshooting guide. So basically what we want to do is add a troubleshooting guide and also expand it based on GitHub issues that we help users with. So as in when we help users, if we think this is something that makes sense, we should add it to the troubleshooting guide, starting with how they can identify this particular issue and then what actions that they can take to mitigate this particular thing. And I think if we can do that, it's probably easier for users who are facing issue. They just come and look at the guide, and after following it, if they still cannot mitigate, then they can go ahead and open GitHub issues. And we want to document the load test results based on all the runs. And the future roadmap maintained as part of the project board. So today we have a project board, and then we're trying to add the new issues that come in to either backlog, to do, in progress. So backlog is basically something that we haven't looked at right now. To do is something that we want to, and we'll probably get to in the next few releases. And then in progress is in progress for the next release, and obviously the last one is just done. So, but what we want to do is we want to maintain the project board and then keep it up to date so that any user who goes and looks at the roadmap knows what we're working on currently, what they can expect to see in the next release, and it kind of gives them the whole picture. And the release management doc, Rita added this. So we have a basic doc right now, but most of the releases I've been doing it. But I think what we want to make sure is go over that doc to see if other contributors are also able to make the release. And then if not, we have to make the doc more consistent so that anyone can go through the doc, cut the release, and go through the whole process.
And just to add, like, I think as part of this, we should define how to, when to patch things, you know, supportability, as it kind of mentioned up there, like in -2 minor versions. So what does it mean when we patch, when do we patch, and which minor versions we actually patch for security issues or bug fixes? And then also, how do we, what are like the supported Kubernetes versions, or just supportability matrix, I guess. That should be part of that doc.
Okay. The next one is metrics, basically the basic system health metrics that show if the system is working. So I think this also, so we already have a liveness probe today for the CSI driver that the CSI community provides. So there's a sidecar container which constantly checks the socket to make sure that the driver is up and running. But we also want to have an option to do readiness probe so that the application pods can rely on that in terms of deployment. So they could do that something with init container to check if the driver is up and running. Because there are scenarios where if a new node comes up, Kubernetes scheduler schedules the workload pod before the driver pod. And in those scenarios, drivers, the workload pod sees mount failures because the driver is not yet running. And it basically just populates quite a few events with mount fail, mount fail. So I think if we can provide a way to do readiness probe, then users can query to see if the driver is running, and then they can actually start their application workload. And basically, we want to see if we can add metrics to identify and expose the drifts between the state of the pods or provider fail to update one or more pods. So basically, when there are a burst of pods that get deployed, we want to make sure that even if a single failure happens for a pod, we want to highlight that and then show that in the driver logs, right? So we have enough metrics to show out of the burst what failed and how many failures, so that we can take the necessary actions by just looking at those metrics. So the next thing is logging framework. So right now we're using Logres, and then in terms of debug or warning, it's the logs are printed out pretty frequently, even with debug. And I think what we want to do is revisit that and switch to using Klog. So I opened a PR last night to switch to using Klog, and also there's a really good blog on structured logging with Klog with V2. So I've gone through that and I've tried to incorporate that into the driver. So that way, what we do is when a user sees an error with a particular pod, they should be able to filter only on that pod in the logs, and they should be able to see the string of events for just that pod.
Does that mean we have to define how we want the logs to be structured?
It does. I mean, right now in the PR, it varies a little bit for different packages because the pod detail is not available for all events, right? Like for node unpublished, we only get the pod UID. And for node publish, we have the pod name. And for the other concilers, we have the pod name as well. But yes, that does mean we have to define a standard. So we probably all have to document that. So when we add new logs, we follow that standard. Also, the next one is basically to audit the current logging. So once we do the K-log changes, I think what we want to do is basically do an audit on all the logs that we have to make sure that we have everything that we need, even across different log levels for debugging. So if a user comes with an issue, and if we can have them increase verbosity and still get all the logs, then that'll be good for us as a first-step debug. And configurable log verbosity is something that we'll be able to achieve with Klog. So as part of this audit, we also have to determine that the different log levels that we define, whether they make sense, if you want to bump the log levels, and we just need to have a complete log coverage so that anytime we have issues, the logs are the single source of truth for us. And in terms of security, basically we want to go through a CNCF security audit. So have the CNCF sponsored security audit go through threat modeling and also the results so that we know that it's secure. And then if there are any vulnerabilities, then we fix them before we call the project is stable. And also for other attack scenarios or threat modeling that we do with the audit as well as outside of it, I think we want to translate those to E2E tests once we have a mitigation so that we know that any future PRs don't break or cause the issue to reoccur, basically. And then we want to add PSPs, pod security policies, so that out of the box, we tell the user how they can configure the least privilege for the driver. And then also the RBAC requirements for each feature. So today we do have all the RBAC rules, but we don't document it. So I think it'll be a good thing to document so user knows why certain RBAC permissions are being required by the driver and for which feature it's being used. So that means if they disable a feature, they can go through the doc and say, yeah, this is not required for this feature, so I'll just go disable these RBAC permissions. Okay, so that covers the criteria for driver. I think the next one for provider is basically to add hand chart support. So for the provider is mostly suggestions based on what we've seen from users and what we are currently doing. So this we can still add to it. But the first thing is basically hand chart support. So today for folks installing the driver and provider, they have to do the installation in the driver repo, then go back to the provider and then install the provider. So I think if we are able to provide a Helm chart in the provider repo with the driver Helm charts as dependencies, then it becomes a lot easier for the user because it's just one-click install. So the idea is that today we are doing it for the key-valve provider. So take a look when you get a chance. The next one is Windows support. So driver added support for Windows in 0.0.9. So I think it'll be great if the providers support running on Windows nodes. In terms of provider changes, the changes are very minimal for actually supporting Windows. I think it requires building multi-arch images. So basically building binaries for Linux and Windows and also publishing Docker images for Linux and Windows. So that's the most that's required for the Windows support. And also provider testing. So we do the driver provider tests on the driver side, but that's again just to validate the driver features. But on the provider side, it's possible there are different backend scenarios that's being supported. So basically, we want to have test coverage in the provider. So that includes backward compatibility tests. So again, this is updates to N-2 minor versions. So this could be the provider versions or the driver versions with whatever the provider is using. And again, determine test gaps and improve test coverage. So this is the basically E2E and unit tests, so the providers are confident before they cut the release. And the high availability applies to this one too. So the provider is basically robust to infra failures, network failures, and other operational failures, because the provider is the only pod that's actually talking to the external secret store. So we want to make sure that it's reliable, because any failure there will just result in the pod mount to fail. So, and then this is an important point, because we found an issue in one of the driver releases where provider binary is invoked, but then there is no context being passed. So if the provider doesn't honor the context, then what happens is it just times out, and sometimes it's just like false negative and the mount succeeds, but then the files are not there. So right now for gRPC, we are passing the context, the parent context from kubelet all the way to the provider. So the provider must ensure that at every request, it uses that context and then it honors it in the right way, so that if it is not able to do it within the context timeout, it just returns an error. And this is the same as the one for the driver. So basically, the provider should be able to handle partial failures, and when driver calls something repeatedly, the provider call should be idempotent, basically. And in terms of documentation, basically, because there is a driver version and provider version, the providers should document the version supportability matrix. So for instance, the latest version of Key Vault Provider has gRPC changes and does not work with provider driver versions less than 0.0.14. So we want all providers to document this supportability matrix. So basically says the minimum version of driver required for each provider version. And also for a provider, basically have a doc which talks about the driver features that the provider currently supports. So like right now, in terms of features, we have sync secret and rotation, and going forward, we'll have more. But from the provider docs, it's basically to say these particular features are supported for this provider. And also, if we want to elaborate more on the docs for those in terms of setup and all that, that'll be great as well. Because it's most of the time users land directly on the provider repo and they go through the docs there. And if you provide a helm chart to also install the driver, they are doing everything just in the provider. So it's good to have these docs there so that the users just go through the single doc, install, setup, and then they just get going with it. And for troubleshooting guide, basically this could be provider specific, and also if the provider wishes to add driver debug there, that'll also be great. But with the gRPC changes, all the provider logs are in the gRPC pod, the provider pod. So that means there are provider specific errors that the user might need to take actions in terms of unauthorized errors and also in terms of like configuration errors. So I think having a troubleshooting guide there for provider specific scenarios will be really helpful. And in terms of performance, basically determine system failure at scale. So this metrics involves the rate limiting, right? So this is basically the scale of API calls to the backend secret store. So we want to make sure that the provider can handle a burst of calls, and then also what is the load and how gracefully it can handle it. So if there is rate limiting, if it's honoring the retry after header, and then atomicity also comes into play, because if it's getting 2000 requests and the rate limit is 1500, it has to make sure the 1500 succeeds, but the 500 failures are all atomic. So like it's all or nothing. So this scale test is basically to ensure atomicity at the provider, and also honoring retry afters and also the rate limiting. And this part is the same as that of the driver, right? So we want to enable all the features that the provider can work with for the driver and then run a set of scale tests. Because if we look at rotation, then the provider is being called periodically by the driver. So we want to ensure that the provider can handle such scenarios. And if it's a limitation, then we can also go and recommend what is a good value to set as the polling timeout for the rotation as well. And in terms of metrics, basically basic system health metrics that show if the system is working. So we don't have any kind of metrics today. So if it's running as a binary, there's no metrics. And for gRPC, we don't have any kind of liveness or readiness health check for the provider uptime. So I think that's something that we should definitely add before we call it stable. And for gRPC server, because that's the direction that we want to go with. So we want to ensure that all providers implement the gRPC server and then they're running the latest version. And in terms of logs, whatever applies to the driver applies here as well. So basic logs for diagnostics and configurable verbosity. So we want to pick a logging framework. So I mean, the provider can pick any logging framework, but the gist is we have enough logs to debug on the provider side, and then also the providers have configurable verbosity. So like debug logs, or if they're using klog, multiple log verbosities are supported, basically, so that the users can run with the least logging level and then switch up if they need to debug. Yeah, I think that covers all of it.
Sounds good to me. One question I do have is, will the CNCF security audit cover the providers as well, or just the driver?
That's a good question.
I think usually is the CNCF project. So in this case, it'll be the driver. But I don't really know how they can realistically do ADEs without the providers. So
Yeah,
we
it's a
can
bit
figure that out. Go ahead.
So yeah, I was just agreeing it's a bit of an odd one because yeah, you can't really run the driver without a provider.
One idea I had on that is maybe there being like a reference provider that uses Kubernetes secrets as the external secrets, like, so it's just like a circular dependency there. But like,
What could go wrong? Just kidding.
I don't know. That's why I haven't written a issue, because it's kind of silly.
Yeah.
But, I don't know.
I do like the idea of like a stub. I mean, I think Anish added like a
Mock provider.
A mock provider. So in theory, they could use that, but well, I guess we'll figure it out when we get there. Like we have to like kick off the whole, like figure out who's like there's a company I think called Trailbits or something. They've done these type of audit for other projects before, so we just have to work with them to figure out how they want to do it, and then we can write issues, I guess.
Yeah, cool. Sounds good.
Any more questions on the doc?
I think it looks pretty good.
LGTM. I guess my question is like, what do we do next? So I love that we did this together. I think we should perhaps think about creating issues and tag them in like a stable a milestone called stable. That's like, I think that's super helpful for consumers of this solution to know, okay, how far are we from cutting a stable release for both the driver and the providers, right? So what do we want to do about creating issues in those in all the different repos, I guess.
Yeah, I think that makes sense. That's the next step that we definitely want to do. Okay. We don't have any other items on the agenda. I just had a question for Tom, not to put you on the spot, but do you know where we are with vault changes for gRPC? Like, just curious.
Yeah, I've kind of got it working locally, but it's not kind of polished enough to actually open it on the repo yet.
Okay.
We're still kind of we've been fairly heads down on getting ready for the next Vault release, but we should be getting some more time to finish off the design in the near future. So then that's the gRPC will be one of the first things we do once we got that nailed down.
Cool. Yeah, I think the plan. Sorry, go ahead, Rita. You're gonna say
Oh,
something.
sorry. I think I was just kind of saying, like, as a user, I think it may be helpful to also like create milestones in the Vault and like other providers' repos, just to give people signal, like, hey, we're working on this, and this is like the day that we think we want to deliver that. I mean, we do see questions on GitHub a lot.
Yeah, I think that's a good idea. We'll do that. I think it's a good way to manage it.
Yeah, I mean, the plan is after all providers have the gRPC support, we will make the default gRPC supported providers list in the driver, so that users, when they install, like, they know that every provider just works. Because today the flag needs to be manually configured for certain providers. So I think we can just have it pre-configured, and then users can just start using it.
Right. Yeah. Sorry, I hadn't realized. Is Vault the last holdout on that? Yeah. Okay. We can try and punt priority on that up a bit.
No pressure.
Yeah, and also on Slack, I posted the issue that Tommy had initially brought up, the service account tokens. So that's still in progress, and I think it's going to land in 120. So that'll be a good feature for us, because we can explore auto rotation with that.
I think also AWS was looking at that.
Yeah.
I don't know if they've been on the call lately, but
Yeah, I mean, I had a brief discussion with Rajat, so they said they're in the design phase. I think they're keeping an eye out for this as well, but probably their design is based a little bit on this as well. So. Cool. I think that's it for the agenda. Any more questions?
Oh, cool. It was really good to see everybody.
Yeah.
Yeah. Thanks.
Thank you all for joining.
Bye.
Bye.